For centuries we thought we knew our solar system, a sun, a few planets and some icy rocks. But hidden worlds, mysterious moons, secretive planets and alien-like landscapes exist right under our noses, waiting to be discovered. Worlds where methane rains like water, volcanoes spit ice and ocean lurk beneath miles of solid ice. In this video we are uncovering 5 of the strangest and most hidden worlds in our solar system, places where science fiction meets reality. And the best part, we'll share the untold stories of the scientists who are cracking these mysteries wide open. From a moon with Geysers shooting into space to planets that could harbor alien life. This is a journey through our cosmic backyard that you cannot afford to miss. Let's begin. Let's start with the chapter 1, Europa, the ocean world. What if I told you that one of the most promising places to find alien life isn't in some distant galaxy but right here, orbiting Jupiter? Meet Europa, a frozen moon hiding a colossal secret beneath its cracked icy crust. This is Europa, our solar system's greatest ocean world, and the scientists determined to uncover its mysteries. Now, what is Europa? Europa is one of Jupiter's 4 largest moons, was discovered in 1610 by Galileo Galilei when he pointed his primitive telescope at the gas giant. At first glance, Europa may seem like just a frozen, lifeless ball of ice. But here is where it gets fascinating. Underneath that ice lies a massive ocean, an ocean with more water than all Earth's ocean combined. Europa is about 90% of the size of our moon, with a surface made entirely of water ice. It's constantly reshaped by tidal forces caused by Jupiter's immense gravity, which stretch and squeeze Europa, generating heat deep within. Now the idea of Europa hiding an ocean started gaining attraction in the 1970s and 1980s thanks to the data from spacecraft like Voyager 1 and Voyager 2. Scientists noticed that Europa's smooth cracked surface looked unlike anything else in our solar system. But the real breakthrough came in 1990s with NASA's Galileo spacecraft. The Galileo mission found something extraordinary. Europa's magnetic field was behaving strangely, as if it was interacting with something salty and conductive beneath the ice, a subsurface ocean. This wasn't just speculation. Scientists estimated that Europa's ocean could be 100 kilometers deep, 10 times deeper than Earth's ocean, and completely global, covering the entire moon. Now here is the exciting part. On Earth, wherever there is liquid water, there is life. Whether in boiling hot vents at the bottom of the ocean or in icy Antarctic lakes, Europa's ocean is heated by tidal flexing, which could allow for volcanic activity on the ocean floor. If hydrothermal vents exist in Europa's ocean like those on Earth, then they might provide the perfect environment for primitive life, even without sunlight. One scientist who has dedicated his life to studying Europa is Dr. Robert Pappalardo, a planetary scientist at NASA. Pappalardo has been a leading advocate for exploring Europa because he believes this moon could hold the keys to understanding extraterrestrial life. In his words, Europa's ocean is one of the best places to look for life beyond Earth. If we find life there, even microbial life, it will change everything we know about the universe and our place in it. Europa also has water plumes, geysers of water vapor that shoot up from cracks in the ice and rise hundreds of kilometers into space. These plumes were first confirmed in 2013 by the Hubble Space Telescope. So why is this so important? It means scientists might not even need to drill through the ice to study Europa's ocean. Instead, future missions could simply fly through the plumes, collecting samples of water vapors to look for signs of life. NASA is taking this search seriously. In 2024, NASA has launched the Europa Clipper mission, a spacecraft designed to orbit Jupiter and conduct multiple flybys of Europa. Europa Clipper will use high-tech instruments to map the ice, study the plumes, and analyze the moon's surface, and will be searching for chemical signatures that could indicate life. In the distant future, scientists even dream of sending a lander or a robotic submersible to drill through the ice and explore the dark ocean beneath. Now the question is, why Europa matters? Europa is more than just another moon. It's a symbol of the unknown. If we find life on Europa, it could mean that life is common throughout the universe. Imagine billions of planets and moons, each hiding their own ecosystem, waiting to be discovered. And even if we don't find life, exploring Europa will teach us more about the chemistry, physics, and potential of ocean worlds, both in our solar system and beyond. A moon that could rewrite everything we know about life beyond Earth. This is Europa, one of the most incredible hidden worlds of our solar system. If this hidden world Europa fascinated you, stick around because we have even more hidden worlds to uncover. Before jumping into the next one, please like, subscribe, and hit the bell icon so you won't miss what's coming next. Now let's move to the chapter 2, Titan, the alien Earth. Imagine a world with rivers that flow, lakes that shimmer, and even rain that falls from thick hazy clouds. But here's the twist. This isn't Earth. This is Titan, Saturn's largest moon, a place nearly similar. What's hiding on Titan's surface, and could this strange world teach us something about life's beginning? Let's dive into the mystery of Titan, the alien Earth. Let's start with what is Titan. Titan is Saturn's largest moon and the second largest moon in our solar system, even bigger than Mercury. It's so unique that scientists often call it the alien Earth because its surface features remind us of our own planet, lakes, rivers, seas, and even rain. But Titan isn't Earth. Its lakes and rivers aren't filled with water, they are filled with liquid methane and ethane, hydrocarbons that could remain liquid in Titan's frigid temperature of minus 290 Fahrenheit. Titan is shrouded in a thick orange atmosphere composed mostly of nitrogen with traces of methane. It's the only moon in our solar system with a dense atmosphere, a key reason it fascinates scientists. Titan was discovered in 1655 by Dutch astronomer Christian Huygens. For centuries, Titan was just a hazy dot orbiting Saturn, its mysteries hidden beneath its thick atmosphere. The real breakthrough began with NASA's Cassini-Huygens mission. Launched in 1997, the Cassini spacecraft reached Saturn in 2004. Attached to it was the Huygens probe, designed to land on Titan's surface. On January 14, 2005, Huygens became the first spacecraft to land on the world beyond the asteroid belt. As it descended through the Titan's cloud, Huygens sent back incredible data and images revealing a surface shaped by rivers, lakes, and seas, just like Earth but with liquid methane. What makes Titan so fascinating is its methane cycle, a process nearly similar to Earth's water cycle. Methane evaporates from clouds and fall back as methane rain. The rain carves rivers and collects in lakes and seas on the Titan's surface. Titan's largest sea, Karkan Mare, is about 1,000 kilometers across, larger than the Caspian Sea. Imagine standing on Titan, dark methane lakes stretch to the horizon, and gentle methane rain falls from a golden smoke-filled sky. Scientists believe that Titan's surface undergoes constant changes, with rainstorms reshaping its rivers and lakes over thousands of years. Now the question is, could Titan support life? Here is where things get exciting. Titan has not one but two environments that could support life. The first one is surface life, methane based. On Titan's surface, the liquid methane could act as a solvent for exotic methane based life forms, very different from life as we know it on Earth. And the second one is subsurface ocean. Underneath Titan's icy crust lies a global subsurface ocean of liquid water. This hidden ocean is warmed by the moon's interior heat, making it a potential environment for water-based life, similar to Europa's ocean. In 2015, scientists detected the first sign of this underground ocean using data from Cassini suggesting Titan's interior could hold the building blocks of life. One of the leading scientists studying Titan is Dr. Sarah Horst, planetary scientist at Johns Hopkins University. Dr. Horst specializes in Titan's complex atmosphere, where sunlight breaks methane into larger molecules, similar to the chemical processes that may have sparked life on early Earth. According to her, Titan is like a natural laboratory for us to study how organic molecules form. If we want to understand the origin of life on Earth, Titan gives us a glimpse of how it might have started. Her research suggests that Titan could hold clues to the chemistry that led to life, not just here but across the universe. The next big step in Titan's exploration is NASA's Dragonfly mission, scheduled to launch in 2027. Dragonfly is a robotic drone designed to fly across Titan's surface. So what makes the Dragonfly so revolutionary? It will hop between locations, exploring Titan's lakes, dunes and icy plains, and it will analyze organic molecules and look for signs of prebiotic chemistry, the building blocks of life. Dragonfly could be the mission that answers the question, could Titans hold alien life? Now why the Titan matters? Titan isn't just a moon, it's a window into the past and maybe the future. It resembles early Earth before life began. By studying Titan, scientists hope to understand how life might arise on other worlds and discover if life can exist in forms we have never imagined, like methane-based organisms. If Titan teaches us anything, it's that life could be stranger and more widespread than we ever imagined. If you're fascinated by Titan and the possibilities it holds, let's move to the next one, which will definitely amaze you. Now the chapter 3, Enceladus, the Geyser moon. Imagine a small icy moon orbiting Saturn. From its frozen surface, giant geysers erupt, shooting water vapors hundreds of kilometers into space. This is Enceladus, one of the most extraordinary worlds in our solar system. Beneath its icy crust lies a vast ocean, a hidden realm that could harbor life. Today we uncover the mysteries of Enceladus. Now let's uncover the mysteries of Enceladus, the Geyser moon, and the scientists who brought its secrets to life. Now what is Enceladus? Enceladus is one of Saturn's 83 moons but stands out as one of the most intriguing. It's small, only about 500 kilometers in diameter, roughly the size of United Kingdom. Its surface is covered in fresh bright ice, making it one of the most reflective objects in the solar system. At first glance, Enceladus seems like an ordinary frozen moon, but then something extraordinary was discovered. Enceladus is geologically active and its icy crust hides a massive global subsurface ocean, just like Europa. The discovery of Enceladus geysers began with NASA's Cassini spacecraft, which reached Saturn in 2004. During its flybys of Enceladus, scientists noticed something strange. The moon's south pole was warmer than expected, and huge plumes of water vapors and icy particles were erupting from fractures on the surface, later named the Tiger Stripes. These plumes shoot water vapors hundreds of kilometers into space, creating a massive cloud of icy particles that contribute to Saturn's faint E-ring. The discovery stunned scientists. For the first time, they had evidence of liquid water erupting from an icy moon within our solar system. Now what's beneath the ice of Enceladus? The geysers led scientists to a groundbreaking conclusion. Enceladus has a global ocean beneath its icy shell. The ocean is trapped between a rocky core and an icy crust that's about 20-30 kilometers thick. This subsurface ocean could be tens of kilometers deep, making it one of the largest reservoirs of liquid water in the solar system. The heat that keeps the ocean liquid comes from tidal forces. Saturn's gravity stretches and squeezes Enceladus, generating heat within the moon's core. This process keeps the water from freezing and fuels the massive geysers. Now the question is, could Enceladus support life? Here is the exciting part. The plumes erupting from Enceladus' surface give us a direct sample of its subsurface ocean. When Cassini flew through the plumes, it detected water vapor, organic molecules like methane, carbon dioxide and ammonia, and it detected hydrogen gas. These discoveries suggest that hydrothermal vents similar to those on Earth's ocean floor could exist at the bottom of Enceladus ocean. On Earth, hydrothermal vents provide energy and nutrition for life to thrive in the darkest and most extreme environments. If similar conditions exist on Enceladus, it is possible that microbial life could exist in its hidden ocean. One of the key scientists behind Enceladus discoveries is Dr. Caroline Porco, the leader of Cassini's imaging team. Dr. Porco was among the first to study the images of Enceladus plumes and realize their significance. According to her, when we first saw the geysers, we knew we had stumbled upon something extraordinary. Enceladus became not just a moon, but a habitable zone in our own backyard. Dr. Porco's work transformed our understanding of Enceladus, turning it into one of the most promising places to search for life beyond Earth. The discovery of Enceladus geysers has sparked excitement for the future missions. Scientists are eager to return to Enceladus and answer one big question: is there life on its ocean? The proposed missions include plume flyby missions. Spacecraft could fly through the plumes again to collect samples and analyze for biosignatures, chemical signs of life. The second one is ice-penetrating landers. Future missions may send landers capable of drilling through the ice to explore the ocean below. NASA's Dragonfly mission to Titan has paved the way to such exploration, and many scientists hope that Enceladus will be next. Now, why Enceladus matters? Enceladus is more than just a beautiful icy moon. It's a beacon of hope in the search for extraterrestrial life. Here's why. It has liquid water, a key ingredient for life. It has organic molecules, the building blocks of life, and it has energy sources from the hydrothermal vents. If we find even the simplest form of life on Enceladus, it will prove that life isn't unique to Earth. It could arise wherever the conditions are right. Enceladus reminds us that the universe is full of surprises, and sometimes the smallest worlds hold the biggest secrets. Now, if you're fascinated by Enceladus as we are, don't forget to like, subscribe, and hit the notification bell for more incredible explorations of our cosmic neighborhood. Now let's move to the chapter 4, Ganymede, the moon of Jupiter. Imagine a world so vast it dwarfs even the planet Mercury. A moon with a metallic core, its own magnetic field, and a hidden ocean beneath an icy crust. This is Ganymede, the largest moon in the solar system and one of Jupiter's most fascinating companions. Now let's begin the journey to this colossal moon to uncover its hidden ocean, unique features, and the stories of the scientists who have worked to reveal its secrets. Now, what makes Ganymede so unique? Ganymede is truly a giant among moons. With a diameter of 3,273 miles, Ganymede is the largest moon in the solar system, larger than Mercury and Pluto. It is the only moon with a magnetic field generated by its metallic iron-nickel core. Ganymede's surface is a blend of bright grooved terrains and darker cratered regions, hinting at a complex and dynamic history. One of Ganymede's most intriguing features is its potential subsurface ocean. Buried beneath an icy shell, scientists estimate this ocean could be up to 100 kilometers deep, more than 10 times deeper than Earth's ocean. The presence of salt in the water could make it conductive, playing a role in Ganymede's magnetic field. This ocean makes Ganymede a prime candidate in the search for extraterrestrial life, as it could harbor the necessary condition for microbial organisms. Ganymede is the only moon in our solar system with a magnetic field, a discovery made by NASA's Galileo spacecraft in the 1990s. Its magnetic field creates auroras, dancing lights in its thin oxygen atmosphere, similar to Earth's northern and southern lights. However, Ganymede's field is constantly influenced by Jupiter's massive magnetosphere, creating a complex and dynamic interaction. This discovery revolutionized our understanding of moons, showing that even natural satellites can have active planet-like features. Ganymede's surface tells a story of world shaped by tectonic forces and impacts. The bright grooved terrains are thought to result from tectonic activity as the icy crust stretched and shifted. The darker regions are older, heavily cratered areas that reveals Ganymede's ancient past. Craters on Ganymede appear flat due to the icy relaxing over time, a phenomenon not seen on rocky worlds. These features suggest that Ganymede's surface is dynamic, reshaped by both internal and external forces over billions of years. Ganymede owes its name and early discovery to Galileo Galilei, who first observed it in 1610 using a simple telescope. Galileo's observation of Ganymede and Jupiter's other large moons, Io, Europa, and Callisto, provided the first evidence that not everything in the universe revolves around Earth. Centuries later, NASA's Galileo spacecraft, named in his honor, became the first to orbit Jupiter and provided groundbreaking data about Ganymede's magnetic field, icy crust, and potential ocean. The work of Galileo and the Galileo mission highlights humanity's enduring curiosity about the cosmos. Europe's JUICE mission, Jupiter Icy Moon Explorer, launched in 2023, is set to make history by becoming the first spacecraft to orbit Ganymede. JUICE will study Ganymede's magnetic field, surface composition, and subsurface ocean in unprecedented detail. It will also explore how Ganymede interacts with Jupiter's magnetosphere, shedding light on the moon's dynamic environment. The JUICE mission is a major step forward in understanding Ganymede and its potential for supporting life. Now, why Ganymede matters? Ganymede is more than just a moon. It's a gateway to understanding the solar system history and the potential for life beyond Earth. Its subsurface ocean makes it a prime candidate in the search of alien life. Its magnetic field and geological activity challenge our ideas about what moons can be. By studying Ganymede, scientists gain insight into Earth-like processes on icy worlds, helping us understand how planets and moons evolve. Ganymede reminds us that even the largest moons can hold secrets waiting to be uncovered. Ganymede is a world of wonders. As we prepare for missions like JUICE, who knows what other secrets this giant moon might reveal. Now let's move to our fifth final hidden world, Chapter 5, Mars, the Red Planet. Mars, a planet of stark contrasts, from towering volcanoes to vast canyons and polar ice caps. Known as the Red Planet, it's long captured humanity's imagination as a potential home for life beyond Earth. Now let's uncover the mysteries of Mars, its unique geology, the search of ancient life, and the missions that have brought us closer to understanding this fascinating world. Now, what makes Mars unique? Mars stands out in our solar system as a world both alien and familiar. Mars is about half the size of Earth, with a diameter of around 4,212 miles. It has the largest volcano in our solar system, Olympus Mons, towering 13 miles high, the longest canyon, stretching over 2,500 miles. Its thin atmosphere, composed mostly of carbon dioxide, gives the planet its signature reddish hue due to iron oxide rust in the soil. Mars' surface features suggest it was once a home to flowing rivers, lakes, and possibly a vast ocean, making it a key focus in search of ancient life. Water is the key to life as we know it, and Mars has tantalized scientists with evidence of its presence. Polar ice caps made of water and dry ice, frozen carbon dioxide, expand and contract with seasons. NASA's Mars orbiter discovered streaks on slopes that may indicate seasonal flow of salty water. Ancient riverbeds, delta formations, and lake beds found by rovers like Curiosity and Perseverance suggest that liquid water was abundant billions of years ago. Mars history hints at conditions that may have supported microbial life in its distant past, and its subsurface remains a prime target for future exploration. Mars' thin atmosphere and harsh climate make it a challenging environment for life today. The atmosphere is 100 times thinner than Earth's, offering little protection from radiation and extreme temperatures. Temperatures can drop to 125 centigrade at night and rise to 20 centigrade during the day near the equator. Dust storms, sometimes planet-wide, are a defining feature of Mars, with winds that can last for weeks. Despite these challenges, regions like ancient lake beds and caves shielded from radiations are considered potential habitats for microbial life. Mars' surface tells a story of a dynamic and evolving planet. Olympus Mons, the largest volcano in our solar system, is a shield volcano that formed from repeated lava flows over millions of years. Valles Marineris, a canyon system nearly 10 times the length of the Grand Canyon, may have formed through tectonic activity and erosion. Impact craters like Gale and Geyser reveal layers of sedimentary rock, preserving the planet's history and offering clues about past water activity. Mars' geological diversity provides a window in its past and a foundation for future exploration. In 1976, NASA's Viking landers became the first to successfully operate on Mars, conducting experiments to search for signs of life. Decades later, rovers like Spirit and Opportunity revolutionized our understanding of Mars, uncovering evidence of ancient water. Today, Perseverance and its companion helicopter Ingenuity are exploring Jezero Crater, once a lake bed, to collect samples for future return to Earth. The dedication of scientists and engineers behind these missions continue to push the boundaries of what we know about the Red Planet. SpaceX of Elon Musk aims to send humans to Mars within the next decade, with plans for permanent settlements. NASA's Artemis program includes goals to establish a sustainable presence on the Moon as a stepping stone to Mars. Challenges like radiation exposure, life support systems, and sustainable food production are being addressed to make human colonization feasible. Mars represents both a scientific challenge and a symbol of humanity's aspirations to explore and thrive beyond Earth. Mars is more than just a neighboring planet, it's a key to understanding our own. Its geological history offers insights into how Earth-like planets evolve over time. Exploration of Mars drives advancement in technology and inspires future generations to pursue science and engineering. Discovering evidence of past or present life on Mars would fundamentally change our understanding of life's place in the universe. Mars serves as a reminder that even the most desolate landscapes could hold the potential for discovery and inspiration. From ancient rivers to towering volcanoes, Mars is a planet of mysteries waiting to be unraveled. As we prepare for future missions, who knows what secrets the red planet might reveal. And with that, our journey through these 5 incredible worlds with our solar system comes to an end. But the universe is vast and there is so much more waiting to be discovered. If you're as fascinated by these distant realms as I am, don't forget to hit that subscribe button and ring the notification bell so you never miss our next cosmic adventure. Your support helps us keep bringing the universe closer to home. Until next time, stay curious, keep exploring, and remember, the journey to the stars begins right here.